Okay, welcome everyone. And I'm going to jump and share my screen so I can talk about the plan for today. So the plan is I'll start out with any questions you might have. And then after that, we're going to get into confidence intervals. So confidence intervals are really, really important in statistics. They come up a lot. And not just in statistics, I shouldn't have said that. They're just really important in all fields. So the idea of a confidence interval is you take a survey, and the survey is just a guess at the population. So if all you have is, a sample size of 200 out of, all Americans, then you don't know what all Americans are. But you have a guess because you've done your survey. And the idea is a confidence interval helps you understand not just what is your guess, but how good that guess is. So you may think, you may have gotten this average, but you might be off by a bit. And the confidence interval helps you understand how much you're likely at most to be off by. And that's what confidence intervals are all about. So we'll start out with a confidence interval for means. So we'll talk about that. And then after a confidence interval for means, we'll get into a confidence interval for proportions. And that is a big part of this class, is that one of the very first things you ever do from now on a question is think about the survey question and say, well, is this a yes, no question? Or is this a question that has a number answer? When people, the person you would ask or the people you ask would always say numbers, or they're all going to say yes or no. And that's a confidence interval for proportions when it's a yes, no. Then we'll talk about sample size. So something I really haven't gotten into is to have a good study, how big a sample size do you need? So we have talked about to use the central limit theorem to be able to use the normal distribution. We've talked about how big a sample size you need. But the problem is that, yeah, you can use the central limit theorem, but you may not have very interesting data when you're done, or interesting results. So having a larger sample gives you a better prediction for whatever you're looking at. And we'll talk about how big a sample you need to have a satisfactory prediction. So that is the plan for today. And we'll talk about the sample size needed if it's about means, and the sample size needed if it's about proportions. So are there any questions about anything? As always, I'm always happy to answer questions. Any questions? Aha, now we're getting a few more people. Good. We actually have a sample size that's big enough to do something. It's not great, but it's better than not having one. So are there any questions at all about anything from the class? I want to remind you again, you finished your project, it's great. So this week, I don't know if you realize, but it's week 6, which means it's an even number. 6 is even. And what do you have on even number weeks? Yeah, exams. So kind of the every other week exam. So at the end, by the end of the week, you have to do the exam. And a lot of that is on confidence intervals, but also on everything before, that we've already done. So it's always weighted more towards the most recent stuff, confidence intervals and central limit theorem. But then there's, a chunk that is old stuff too. And that's how I've set up all the exams. So any questions about anything? Okay, if there are any questions, I have a question for you. And I'll let you know that the chat box is not public. So the world isn't going to see your answer to this question. I can't force you to answer, honestly, but hopefully you do. So here is the question, because it's a bit personal, but hopefully you can answer it. And the question is, how old were you when you experienced your first passionate kiss? By the way, your mom kissing you on the forehead is not a passionate kiss. So it's got to have romance involved. So if you say 2 years old, you can't be romantic at 2 years old. Okay, so put in, and by the way, if you've never kissed anybody, if you never had a passionate kiss, just put how old you are now, because that could have happened. And I'm hoping everyone does, because we don't have a giant number of people here. So it'd be great if you all typed in the chat box. And let's see. Okay, I think everyone's put it in. So I'm going to put in the numbers. And what we have are 12, 12, 15, 15, and 14. All right, so what I'm going to consider all college students, how about in California, as the population. And by definition, you are college students. And when I say in California, I mean taking a class in California. So even if you're living in some other state, you're taking this class. So you're by definition a California college student. So that's going to be our population. So there's a lot of things to think about. One is we can look at these numbers. And in fact, I'm going to take these numbers and let's take a look at the calculator. And I'm going to pop these into the one variable stats. I'll think of this as a sample standard deviation because you're a sample of the population. And I hit calculate. Okay, and I got a mean of 13.6 and a standard deviation of about 1.5. So round to 1 decimal is probably fine. So let's go back. And we have a mean of 13.6. So let's pop in an equation. And this is an X bar. It was a sample. So let's make a bar on that. That is, I think there's a way of doing it. There it is. Okay, so X bar is, again, 13.6. I think I typed 5. And the standard deviation was 1.5. And the standard deviation is S, not sigma, because it's a sample. Any questions on that first? So this is the sample mean and the sample standard deviation. So can we say that the population, for the population of all California college students, that they average an age of 13.6 for their first kiss? Okay. We definitely can't say that. So here's the harder question. Okay, we can't say that the average of all college students is 13.6. But is 13 versus 13.6 our best guess at this point from the information we have here? Yeah, it's a best guess. And if you remember last week, we talked about an unbiased estimator, and the sample mean is an unbiased estimator for the population mean. So that means this is our best guess. Now comes a harder question. How good a guess is it? Does that make sense? So do you think we might be off by 100 years? Yeah, hopefully not. Okay, couldn't be on the downside because you can't have a negative age, right? And I don't think the average first age of kiss is 113.6. All right, so I feel very, very comfortable that I'm off by less than 100 years, right? A bigger font, I can do that. How's that? Okay, so I feel very confident that I'm not off by 100 years. Do you think I could be really confident that I'm not off by more than 0.1 year? Which is like a month ish. Yeah, the answer is no. The standard deviation is 1.5 for one thing. And the standard error, so now let's use the central limit theorem. The standard error is going to be 1.5 over the square root of n. And 1.5 over the square root of n is 5. We only had 5 people answer this question. So 1.5 over the square root of 5, let's do this. Is about 0.67. So the standard error, I'll just write standard error. How about SE for standard error? Was again about 0.67, I believe. Yeah, 0.67. Okay. So based on that standard error, we're probably not, a bunch of years off because the standard error is less than a year. Any questions on that? Okay, if we assume, okay, and let me ask you, do we need to assume the population distribution is normal to use the normal distribution for thinking about samples, for the sampling distribution? Do we need to assume the population distribution is normal, the distribution of all ages, first kiss ages in California? Do you need to make that assumption that is normal? Okay, I saw a no. One more guess. Yeah, the answer is yes. The answer is yes. And you look at the sample size. What is the sample size? It's 5. Why is that important? 5 is less than 31. So we have a small sample size, which means we must assume normality. Any questions on that? All right, so first thing, again, don't take this particular example as a great scientific study. This would be terrible because our sample size is way too small. What's the other thing we must assume? That's probably wrong. Any ideas? And the hint is, think about the first week of class. Any thoughts? I don't see y'all jumping in. We have to assume that there's no bias, that you all are representative of the state. Okay, and there is no bias. Okay, which is a very bad assumption too, because again, this was complete convenience sampling. Do y'all agree? Since I just asked y'all. So convenience sampling is, again, one you would never use this in some published paper. The sample size is too small. This is biased. It's awful. Okay. And by the way, do you think this kind of stuff happens in the real world sometimes when people are doing research? Yeah, the answer is yes. Okay, and it's kind of sad. I think I've mentioned I've done some statistical consulting for different places, and I remember one time, my job was to look at their data and come up with conclusions that they can have, and they had a sample size of 5, and it was complete convenience. It was horrible. It was just like this, but they thought it was some scientific thing, and I'm like, no. So I gave them the bad news. So the hope is by the end of this class, as in this course, you all will be able to look at a study and have a good idea of whether it's a well-done study or not. Okay, where like this is a terrible done study because I just asked whoever was easy to ask. I asked a sample size of 5. Just not good. Any questions on that? All right, so we got to make assumptions. And remember, what are the first 3 letters of the word assumption? Exactly. So you never want to make an assumption. Okay, and after that, after the first 3 letters, it's about you and me. So making assumptions, making an ass of you and me. You ever thought about for assume. So be careful about assumptions. It usually means that you shouldn't be doing this. Okay, but I wanted to give you an example. So let's make the assumptions just so we can. We're going to assume it's normal. And because we assumed it's normal, we can draw a picture. And here's the picture. So first thing is this, what we're going to do is we're going to create a confidence interval, which is an interval at which you can say you're confident that the population mean lies within. Doesn't mean you're 100% reliable, but it means that, you might stake your reputation on it. You may not stake your life on it, but your reputation you might stake on. Okay. So, once in a while, in the real world, you do an oops, but you don't want to do the oops too often. Okay. And in fact, the standard percent for what's called the confidence level, which is kind of like how confident you are that you're right, is 95%. And that was actually decided, I think, in the 30s by the New York Times. They're the ones that came up with it. It wasn't mathematicians. So this is the picture because we have a normal distribution. Our X bar is the center because we want to see how far off from our X bar it's likely to be. And then we're going to say, well, we're no more, we're likely to be between a couple numbers. And that distance from the sample mean to what you say that as far as you need to go before you say, yeah, you're comfortable with that, that distance is E, which is called the margin of error. So the margin of error is how far off you are likely to be no more than for the actual population mean compared to your sample. Okay, any questions on that? All right, the area in between this how far offs, that's called the confidence level, CL for confidence level. And for example, if the confidence level is 95%, then this area that's shaded will be 0.95. Any questions on that idea? If there's 95% inside, how much is outside? Yeah, 5% outside. If there's 5% outside, how much is to the left-hand side? This little white area. Yeah, that'd be 2.5%. So the idea, if you wanted to, is you could actually find out what this X minus E value is by taking your low as negative 99999, taking your high as blank, because that's what we're trying to find, taking your mean as 13.6, taking your standard deviation as 0.67. Do you see that? And taking your P as 0.025. 2.5% is 0.025. And that will give you this value right here. And you could do the same thing over here by saying the low is blank, the high is 99999, and then same mean and standard deviation that we talked about before, and that'll give you that value. Does that make sense? Does everyone understand what I just talked about? Using that calculator that we've been using with the normal distribution? Okay, so that'll work. Okay, that'll work. And that'll give you those values. But I'm going to allow you to be lazy. You're probably going to be happy about that. I want you to understand what I just said, but I created a calculator so you don't have to do all of that. So I'm going to save you some time. Okay, but I do want you to understand this picture. I could ask you, say, some true false questions on this picture, other questions for understanding it. But in the real world, you're going to use a calculator to find the confidence interval with a direct little calculator. Any questions on the idea? All right, I'm going to do it using this data. And the next thing I'm going to do is I'm going to go to my calculator, go back to my calculator. And I want a confidence interval. So we're over here in this confidence. So which one is it? Confidence interval for mean with statistics, confidence interval for mean with data, sample size for mean, confidence interval for a proportion. Which one is it that we need? Yeah, it's number 10. We have data. It's a mean because it's a bunch of numbers, right? And it's a confidence interval because that's what we're interested in. I'm going to paste the data in. That was 12, 12, 15, 15, 14. Any questions so far? Okay, and then the confidence level is 0.95 because I want a 95% confidence level. Stop me if you don't understand something. And I hit calculate. Okay, and by the way, it redoes the X bar and the S. So you actually didn't even need to go to the calculator that we had before. You can jump into this one. But more important that we have the lower bound and the upper bound. And I'm going to use 1 decimal place. That seems about right, for need. Nobody cares about 2 decimal places for age of first kiss, except when you're actually kissing. Then you care which time, what moment it is. But if you're looking at average age of first kiss, 1 decimal place is fine. So 11.7 to 15.5. Any questions on the lower and the upper bound? So I'm going to go back. And I'll make it bigger, don't worry. This is our confidence interval. In fact, I'm going to write 95%. Whoops. Over here, 95% confidence interval. Any questions on that? Any questions? All right, so we want to interpret this confidence interval. Is it always 95%? Really good question. Okay, so I will tell you in terms of the real world. In the real world, social science is always 95%. So if you're going to do a study in psychology or sociology, they always use 95%. Medicine may not use 95% because do you think it's okay? Let's say you're doing some medicine where it's for, I don't know, making your face pretty or something. But you're doing a confidence interval for, how many deaths you get. You don't want to be wrong. Does that make sense? You don't want to kill people. So if it's a life or death situation, 95% is not what you would use. Then use the 99.99 or something. Does that make sense? So when I worked for the Forest Service, actually, they wanted 90% because they didn't have enough funds to have a good confidence interval in terms of a good percent. So they actually had less. But social science is always 95%. Media or news is just about always 95%. So if you're reading a news article and it doesn't say, it's 95%. Got it? On a test, I could ask you anything. But I mean, you saw the calculator. It wasn't very hard to throw in. If I asked you 0.92%, put in 0.92 instead of 0.95. Do you agree that that would be easy enough? As long as you know what you're doing. Okay. So let's take a look. So the first thing is what we can say is to interpret this interval. with 95% confidence, the population mean age of first kiss for all adults. Okay. By the way, we never do a study with children because we don't want to get sued. For all adults involved in, let's call it stats classes, is between, now let's write down the ages, 11.7 and 15.5. 11.7 years old and 15.5 years old. So I didn't know what it was going to be before I started this, so I had to leave that blank until I put it in. So I want to note a few things. Do you see what's in red? So first thing, if I ever ask you to interpret the confidence interval, start here with 95% confidence, okay? Or 99% confidence or whatever that number is. But it'll help to remember it always starts with the word with, because that'll get you going. Sometimes knowing how you start gets you moving. Does that make sense? You must refer to the population when you're talking about it. Okay, we're 100% confident about the sample mean because we took it. We know the sample mean. It's the population mean that we can't be 100% confident about. If you don't have the word population, for example, on the exam or on your discussion reply, what's going to happen? I'm not that mean. But you'll lose points. I wouldn't give you a 0 if all you had if you missed the population, but I take a point off. Okay, and I'll let you know. And you don't want to lose a point on something that easy to just put the word population. So you have to refer to the population when you're talking about confidence intervals. All right. One thing you might look at is it's 11.7 years old and 15.5 years old. Does that give you a good idea when people are having the first kisses? Sometime, before you're 12 and after you're 15, in terms of average age. That's kind of a big spread, isn't it? What if you said that's really too big a spread? I don't want that big a spread. I want a confidence interval that has a smaller margin of error. Okay. So by the way, the spread between 11.7 and 15.5 is twice the margin of error. Because you have the sample mean, which is in the middle in this picture. So your sample mean, you have these two numbers, and the difference between these two numbers is 2 of the e's. Because from here to here, from x minus e to x bar minus e to x bar is an e different distance. And from x bar to x bar plus e is an e distance. So this full distance is twice margin of error. But we might say, well, 11.7 and 15.5 is, I'm not getting any information. Kind of knew that before I even asked y'all. Does that make sense? What if I wanted this to be a smaller margin of error? What could I do? And the hint is that there's actually 2 things you could do. And so any thoughts on what you could do to make this interval not so wide? Okay, your idea of increasing the confidence, it's a really good idea, but you're backwards. If you want to be more confident, then it's going to be wider. So if you decrease the confidence, then you could be more narrow. So for example, I am 1% confident that is like between, let's see our numbers, 13.5 and 13.7, something like that. Do you see that? So I could make it really narrow and be just a tiny bit confident. But do you think I'd be okay if I was wrong 99% of the time? If you're only 1% confident, you're wrong 99% of the time. That sounds like a really bad idea, doesn't it? So yes, you can decrease the confidence level by being less confident, and that'll make the margin of error smaller. So, but again, who wants to be being less confident may not be good. Do you see that? So that is one possibility. You can do that. What's another thing you can do that's much harder, but you'll get better results? What's a big issue with this study? Yeah, we can increase the sample size. So we have a sample size of 5. So our margin of error is huge. Remember that the central limit theorem is you divide by the square root of n. Remember that? So if instead of 5, we asked 500, square root, so that would be multiplying by 100. Square root of 100 is 10. So then we would decrease that width by a factor of 10. So instead of being off by, this is like around 4 or so, you'd be off by less than a half. Do you see that? But again, there's pros and cons. What's the problem with asking for 100 people? You could do a stratified sampling, for example, and kind of not have so much bias. You don't have more bias if you have a bigger sample. That just has to do with how you choose your people. What if I told you on your project, on project 1, you had to survey 400 people? Would you be okay with that? You don't have time to do that, right? Okay. And if you had to hire somebody, you may have the time, then it doesn't take you much time, but it's gonna be very expensive. So again, there's always pros and cons. You can decrease the width of the confidence interval or the margin of error, but at an expense of money if you're going to hire a company, or time if you're doing it yourself. Does that make sense? So nothing is like everything is wonderful. You always have to give something up to get better results. Any questions on that idea? All right, so now I want to talk about what it means to be 95% confident. So here's the way I'm going to state it. Think of yourself as a professional researcher, where what you do is you do some research and you ask, I know with this one, a professional probably wouldn't ask 5 people. They probably do bigger sample sizes, but let's pretend. And you ask 5 people, and then you ask 5 different people and got a different confidence interval. And then you ask 5 different people and got another one. You could do that all day long. So if you were in the business of sampling, then each time you do one of those samples, you're going to get a confidence interval. Is that clear? You're going to pop in the calculator and it's going to give you a confidence interval, and you'll get a different one. Every time you ask 5 different people, you're going to get different answers. Do you agree? So if you were in the business of sampling, you could get many, many, many confidence intervals. And the goal or the hope is that your confidence interval contains the population mean, because that's what you're trying to do. You're trying to say, I have a good estimate for the population mean. And if you're in this business of creating confidence intervals, then 95% of the time, your goal will be satisfied. And 5% of the time, you'd be off and you wouldn't have the population mean. Does that make sense? So kind of in kind of shorter answer is, if we sampled many groups of adults involved in stats classes, then each of these would result in a different confidence interval, and maybe even many groups of 5 adults, because that's how many we asked. So every time you did it, you'd have a different confidence interval. 95% of these intervals will contain the true population mean age of first kiss. Any questions on this idea? Okay, so I want to really note though, because everybody gets confused on this, and I'm hoping you don't. So this first sentence, with 95% confidence, the population mean age of first kiss for all adults involved in stats classes is between 11.7 years old and 15.5 years old. That is the interpretation of the interval. Got it? So maybe I'll even boldface the word interval. Now, this guy, what I just did is, if you sampled many groups, that is the interpretation of the confidence level. So let me write that down. So don't get the confidence interval confused with the confidence level. The confidence level is 95%. The confidence interval is 11.7 to 15.5. They're different things. Any questions at all on this idea? Any questions? Okay, so what I have put that hopefully will help you is I created a template, and you're welcome to take notes. This is a video, you can rewatch it too, but you could say with whatever confidence, it might be 95%, it could be 90%, whatever it might be. The three main ones that are used are 90%, 99%, and 95%. So with whatever confidence is, it can be concluded the population mean, whatever might be, in this case, age of first kiss, is between whatever numbers we have, something and something. So it's a nice little template. But promise me, when I ask you to write out the interpretation of the confidence interval, don't put X's in, please. You need to fill those in. Got it? Okay. And similarly, interpreting the confidence level template is if many samples of however many are taken, in this case, we had 5, then each would produce its own confidence interval. Whatever percent, like 95% or 99% of these confidence intervals will contain the true population mean. In this case, it's age of first kiss. And 1 minus that, so for a 95% confidence, then 5% won't contain the true population mean. Any questions at all on kind of the confidence interval templates? Okay, so I'd let you know, I'm going to remind you again, even though I've always reminded you today, you're going to have to do that for the discussion post reply, both of these. And you're also going to have to do it for the exam for this week. Okay, so be ready. You shouldn't be surprised because I'm telling you now. So make sure you practice it. One thing I recommend is when you're doing the chapter assignments, because those are computer graded, they can't read your sentence and know if you've written it correctly. I wish I was like an amazing artificial intelligence programmer that could make that happen. I mean, I could do some AI, but that would pretty much, I would have to quit my job to do that. That's how much time that would take. So there's no way I can make that happen. So it's multiple choice. So force yourself, instead of just to click on whichever one you think is right, force yourself to write out the interpretation before you look, and then go and click the right one. So that's my strong recommendation to learn this stuff, so that when you have to do the exam and the discussion reply and your project, by the way, project 2, now that project 1 is over, I can start hinting about project 2. Any guess on what a big part of project 2 is going to be about? Yeah, confidence intervals. Okay. So it's going to be about confidence intervals and something called hypothesis testing, which is next week. So I can't talk all about project 2 now because we don't have the hypothesis testing yet. But confidence intervals are a big piece. And it's actually going to be something that relates more to a couple chapters from now, chapter 10. And we'll get there, I promise. Okay, and then just note that when you're talking about a confidence interval for a population mean, then we use the central limit theorem. So you definitely need a sample size over 30 to have anything reliable. Because in the real world, you don't know something's normal. And remember, if you say you assumed it, then you're making an ass out of you and me. So you need a sample size over 30. Okay, and you have seen that in your project. That is the reason why it was a requirement to have over 30. Because if you don't, I want you to just have that ingrained in your soul that you need, without a sample size over 30, you really don't have anything that's worthy. Any questions on that? Okay. Now time to talk about proportions. So here's a question I have for you, and see if you can guess. What percent of Americans are satisfied with America's abortion policy? So that's been big in the news in the last, year or so. What's your guess? Just guess. Don't worry, you're not gaining any points or losing points on it, but can't hurt to guess. Okay, 20%, 46%. Okay, 15, 37, you're all over the place, which is fine. Again, this is not a test or anything. I'm just curious on, what you think. All right, so if you really wanted to find out what percent of Americans are satisfied with America's abortion policy, what would you do? You do a survey. Okay, so you would do a survey, and it's a very simple question. You would say, are you satisfied with America's abortion policy? And what would the answers look like? What would someone say to that question? Answer? Yeah, it's a yes or no question. So very important to be able to identify when do you have a yes, no question, and when do you have a quantitative question, right? How old were you when you had your first piss is not yes or no, right? I was 13, by the way. But this is a yes, no question. So then you survey and you look at the results. Now, we don't have time to do a really good survey. So instead, we're going to cheat and we're going to use someone else's survey. Sound good? So I'm going to go to, this was Gallup poll, and they did this survey. And kind of a not so happy article. America's off a gloomy state of the nation report. Oh, well. And I'm not going to read the whole article because we only have so much time. But what we can do is we can scroll down a bit. And by the way, let's look up here. The third column is 2022. That's this year. That's when they did it this year. And what we know in terms of abortion policy, I remember it was in there somewhere. There it is. So that's this one right here. 24%. Any questions on that so far? Okay, so 24%. And I'm just going to write p hat because it's easier to write. Oops. Is equal to 0.24. All right, I need some more information in terms of what they did. So I'm going to scroll to the very bottom. Almost very bottom. And look at survey methods. And by the way, when you first open it, it looks like this. And you click that and it shows it. And the main thing is they surveyed 811 adults. Okay. And the interesting thing, one of the things that we can do is we can look to see what they said. So they surveyed a random sample, which I don't believe. Do you believe it was a truly random sample? Not because there's going to be some bias. There's going to be always voluntary response bias on these kind of surveys, but they did their best. Okay, so it was a sample of 811 adults. That I believe. No reason to lie about that. Okay, and for results based on the total sample of national adults, the margin of sampling error, so that's our E, our margin of error, is plus or minus 4 percentage points at the 95% confidence level. So one thing I like about Gallup is they actually state it. Okay, you have to go to the bottom and click something, but you can actually find out this. So let me write this down. Let me see this. And I want to see if they're right. And I didn't check. We're gonna find out. So let me copy and paste what they said. So that's what they said. Let's do it. Okay. Oh, we need to look at one more thing. And that was 811 adults. So I want to copy and paste that. All right, so let's do it. And what I'm going to do is I can go back to the calculator menu. And what calculator number do I want to do? Yeah, this one's 12 because it's the yes, no question. And proportions are for yes, no questions. So I can click 12. We had N. N again was 811. It asked for X. How do you get X in this situation? How do I find X? Because we're going to do some work. It's not shown here, but there's enough information to get it. Any ideas? Not seeing, I'll jump in. Okay, so if we had 24% say yes, and there are 800 people we asked, you take 24% of 811, which is 0.24 times 811. So 0.24 times 811, I click here. And that's, we should round to the nearest whole number because you can't ask 194.64 people. So let's round to the nearest whole number, which is 195. We're going to use 0.95. We're testing to see if they got it right. Oops, sorry. There it is, 0.95. And hey, calculate. I tried to make it easy. And to the nearest whole number percent, it looks like it's between 21% and 27%. Any questions on that? Or 0.21 and 0.27. Any questions? Any questions on this so far? Okay. By the way, how far are these apart? Or even better, how far are they from 0.24? Yeah, they're 0.03 or 3%. And what I found is that Gallup tends to overestimate their margin of error. I'm not sure why, but it's not plus or minus 4%, it's plus or minus 3%. And I've noticed that a lot. I'd say more than half the time they overestimate. So I have no idea what's going on with them. But it really is a plus or minus 3%. Any questions about that? Just a note, we can say with 95% confidence, and now we can say between 21% and 27% of all Americans adults. And again, the survey was about, are they satisfied with the nation's policy regarding the abortion issue? And was it issue? Issue. By the way, are most people satisfied? Yeah, definitely not. Okay, 21% to 25, 27% is not most people. It's not even close. So what that says is America's not very happy about this. Okay, that we can be very confident about. Do you see that? Okay, some people are, but definitely not even close to a majority. Not even a third, definitely not even a third of Americans are. Do you see that? Because a third would be 33%. Any questions at all on this? Okay, we can also say, now let's interpret the confidence level, is that if many groups of 811 adults were surveyed, each would result in its own confidence interval. 95% of these confidence intervals will contain or include the true population proportion of all Americans who are satisfied with the nation's policy regarding the nation's abortion issue. Any questions on interpreting either coming up with the explaining what the confidence interval means or interpreting the confidence level? Any questions at all on this example? And one of the things I love about this class is it is so easy for me to come up with like relevant topics that are in the news today. That nobody, I don't think I've ever been, accused of teaching a bunch of irrelevant, useless stuff in this class. Hopefully you all get it. That this is a big deal. Okay, understanding this is very important to understanding pretty much everything that's going on. Okay, not just some college class, but the world. So we really could understand how to read this survey. Any questions on that? All right, so the next thing we want to do is think about sample size for a mean. So for example, we did this age of first kiss thing, right? Did we have a big enough sample size to be okay and happy about the results and say that interval was small enough? Right, we asked 5 people. Were we satisfied with what we got with the results? Well, not for what we had, but were you satisfied? Do you have a really good feel right now for the age at which stat students on average have their first kiss? Okay, yeah, no. Okay.
Well, when you asked the question, you said passionate kiss is different than your
First
first
passionate kiss. Yeah, first passionate kiss. Yeah, I was just
And
shortening.
that's different than my first kiss. So it's kind of a
Yeah, first
biased
passionate kiss.
question.
But even if we
Okay.
did say passionate kiss, was our I mean our numbers, let's go back and look at the numbers again. Be 11.7 and 15.5. Do you have a really good idea on the average age of first passionate kiss?
I just remember my first passionate kiss and my first kiss.
You definitely know your own,
Big
but how about
difference.
the average age of all Americans? First passionate kiss. No, because
Definitely not.
like between 11.7 years old and 15.5 years old, I was a totally different person when I was 11 years old and when I was 15 years old. Okay.
Yeah, definitely.
Okay, this doesn't give me any clue about our society. This is terrible. We might be much happier if, let's say, our margin of error was only a half a year. And that might be okay. And then you have a good feel for it. So if you're only off by like a half a year, that means the whole interval is only going to be a length of with 1 year. Do you see that?
Yeah. So my first kiss was 12, but my first passionate kiss was at 15. So it's a
Right.
big difference.
Right. But I'm going for the passionate. I'm going for the passionate.
Okay.
Yeah. Yeah. Because I probably had a first kiss when I was a baby because my mom probably kissed me on the forehead. Probably when I was 0. Because I think my mom did that. It's a normal thing. I know my daughter was 0 because I kissed her on the forehead when she was born, but passionate kiss is different. And the point is this width doesn't tell you anything. Do you see that? It's all over the place. So let's suppose we wanted to know, instead of this big long width, we wanted something that was just maybe a half a year, because then we would be more comfortable with having results that we understand. So the question is, how many people would we need to survey? Do we have to survey 1 million people? Do we have to survey just 10 people? How many? And you can guess all day long, but what we need to do is we need to come up with formulas. And the formula comes from the central limit theorem. So we know the central limit theorem says sigma sub x bar equals sigma over root n. And the error is going to be z times sigma sub x bar. And what's going on there is that it's how many standard deviations you are times the number of standard deviations, right? Z is how many standard deviations away from the mean. And if you multiply that by how many standard deviations, that's what we've got. If you plug in sigma over root n, you get z sigma over root n. And that's the error. Now, I'm not going to torture you with the algebra, but if you multiply left and right by root n, divide by e, and square both sides, you get n is equal to z sigma over e quantity squared. So this is the formula for deciding how many people you need to survey to come up with the, if you know what the standard deviation is, and you know how far you're okay being off by, that's E. And you know your Z, which is going to come from your confidence level. So for example, a 95% confidence level turns out to be 1.96 for Z. And we did that on chapter 6. Okay. And a 90% is 1.645. I don't expect you to know those, but I just have them memorized. Okay. But you can come out with those using the normal distribution calculator. Does that make sense? All right. But then I did something that actually a few people got mad at me for. And that is I created a calculator that does the whole thing for you. So you don't have to do all of that. Okay. By the way, when I say a few people got mad at me, do you know what kind of people I'm talking about? Yeah, the teachers, because I made it too easy. Students have never gotten mad at me for this, but I will let you know there are some people that say we don't want, you shouldn't have that, but I did it anyway. So we can actually find out n. So to say we want to find out how our sample size, if we want a margin of error of 0.5, a half a year, because that would be nice, right? And we know our standard deviation, our best guess is 1.5 was our standard deviation. We can go back to the calculator menu. And what number do you think we need to do if we want to find out how many people we want to survey so that we have good stuff? Yeah, there's going to be number 11, sample size for the mean. Is that clear to everyone? So I click sample size for the mean. And basically what I did is I coded this up so it puts it into that formula. So our sigma, again, was 1.5, because that's our best guess for sigma. And you typically never know exactly sigma, so you use S. Our margin of error, you want it to be a half a year, so 0.5. If we want a 95% confidence level, you can go 0.95. And calculate n. So what this says is we would have needed to survey 35 people. Any questions? Any questions on this? Okay. Do you agree this is easier than using that formula? Okay. So I apologize, by the way. Some people aren't very happy that I did this. No one in our college, by the way, but some of the other colleges, it's like, no, you made it too easy because they wanted to get you guys to do it. So I, sorry about that. But anyway, that's how you do it. Okay. So one thing in terms of the real world, you need to know sigma. So the way what you usually do in the real world is you do a survey of like 5 people or whatever, typically a little bit more. Use that, just like we did, use that as our estimate so we can pop that in, and then it'll tell us how many people we need to survey for it, for a more useful survey. Any questions on that? Okay, so that's sample size for a population mean. Okay, so I want to make sure that you understand there's 2 different types of questions on sample size. One is how many people do you need to survey so that you have a normal distribution for the sampling distribution? What's the answer to that? What's the smallest number of people you could survey so you have an approximately normal? 31. 31. Remember, over 30. 30 is not over 30. So 31 is over 30. And that's what we're using in our class, by the way. So that's a different question than how many people do you need to survey to make sure that you have a margin of error of less than 0.5. Do you see that? So make sure you understand the 2 different questions, and they are different. One is to make sure you have a normal distribution, and the other is to make sure you have a small enough standard error. So they're different questions, even though they're both asking for sample size. Okay, so that gave us that one. Now let's do another example. But now we can talk about sample size needed for a proportion. So we can find the sample size needed for a confidence interval for a population proportion. Okay. And with means, you have to have an estimate for sigma, or you just can't do it. With proportions, you don't. Okay. If you have an estimate, then sometimes you can get away with a smaller sample size. If you don't have an estimate, you can still come up with your sample size, but it'll often be a little bigger than you really needed. So here's an example. Suppose you wanted to find a 99% confidence interval for the population proportion of cars in the United States that are electric vehicles. Any questions on that? And you want a margin of error of no more than 3%. How many cars must you look at? Any questions on the question? Okay, I'm not even going to torture you with the formula. There is a formula like I showed you before. This one's even worse. Instead, we can go to our calculator. And what calculator number do you think we need? Yeah, this one's 13 because we're trying to find a sample size for a proportion. Is that clear? So I click on that. And notice that I've programmed it. So you can either click you don't have an estimate, or you can click you do if you do have an estimate. It'll ask you for the estimate. If you click on don't have an estimate, it doesn't ask you for the estimate. Any questions on that? So we don't have an estimate. We wanted our margin of error to be 0.03 or 3%. We want our confidence level to be 0.99. Any questions on that so far? And I hit calculate in. And I got 1,844. So what we can say is look at 1,844 cars. Any questions at all on that? Okay, then that was part A. If there's part A, you know there's going to be a part B. So part B is, let's suppose you looked at last year's data. And let's suppose that last year you found out that 2.2% were EV, or electric vehicles. How many cars would you need to look at to have a 99% confidence interval? So it's the same survey. But the idea is now you have an idea of the percentage of cars that are EV. And when you have an idea or an estimate, sometimes you can get away with surveying fewer. Remember, it costs a lot of money or it takes a lot of time to do a big survey. So if you can survey fewer, then you have reduced your cost. Okay, but you can't survey fewer blindly. You got to really know that you're going to have a small enough margin of error. So now what I can do is I can go back to the calculator. I can say I do have an estimate. And that was, again, 2.2%, which is 0.022. So I want to stop any questions at all on this with estimate versus without estimate. And I hit calculate N. Did it change? Yeah, drastically. Okay, now I only need to survey 150. That's a lot easier. That's a lot easier than 1,844. That was 159. Any questions on that? Okay, let me do an interesting one. Let's suppose you work for the CDC. Do you know what the CDC is? Yeah, Center for Disease Control. And do you know what they're doing right now? What's one of their main things they're looking at? Yeah, looking at COVID. And right now they're looking at babies, actually, because right now they haven't approved shots for babies yet, right? Lisa, unless there's been news I haven't read, in the last couple of days, but I haven't seen it. So how many babies do you think they need to have in their testing before they can open it up? Does that make sense? So there's a lot of things. One is, what do you think a good margin of error might be? How much off by might be okay in terms of the proportion of babies, for example, that get COVID, even though they've been vaccinated? And, and again, that's, up to the CDC. That's not a math thing. Is, how comfortable are they to be off by, say, a couple percent versus a 0.5% versus 10%? What do y'all think? I'll just use that one because I'm not a CDC person. I know some of you are going into medicine, so you know better than I do. Okay, let's go 2%. Okay, so if we wanted a 2%, no more than a 2% margin of error. Do you see that? And how confident do you think they want to be for babies? Okay, 99.999. Okay, you don't want to kill babies, right? Okay, so we can do that, and we don't have an estimate. So that's add 3 more nines. Our margin of error is 0.02, and I calculate n. So you need to actually have 12,195 babies in the test, in the study, before you can think about approving. Okay, and they make those, that's how they make these decisions. They have to do a test. Okay, by the way, for adults, the test for the number of people that got vaccinated in the testing, anyone know what it was? I do, by the way. Anyone know how many people they vaccinated before they knew it was actually safe in their testing? No, not 0. Definitely not 0. Remember, this is before they open it up to the whole world. You don't want to do 0. You want to, because then you could kill off the whole world, and you probably don't want to do that. Okay, it was 20,000. It was 20,000, and again, that came from the margin of error they were okay with, and the confidence level that they wanted. Yeah, no, they didn't want to kill the whole world. The CDC is not evil. Okay, they're bureaucratic, but they're not evil. They're doing their best. So anyway, that was, a real life thing. You probably all know the story that they did a test before they had ever opened it up to the whole world. And they did it on adults before they did it on children, for good reasons, because you don't want to, not that you want to kill adults, but you usually want to protect children a little bit more. So that's why they did the adult studies before the children's study. Any questions at all on finding the sample size for a confidence interval when you know what margin of error you're comfortable with and you know what confidence level you're comfortable with? Any questions? All right, so that is actually the last topic, which means it's a secret word, but it really isn't a secret word because I want to mention something after this. It's a secret letter, and it's T. Okay, it's T. So let me explain why I'm having this as a secret word. And it has to do with something very important. When we did our first example, there's an S here. Do you all see that? So we have an S because it's a sample standard deviation. Is that clear? There is no way we can know the population standard deviation. And in fact, if we did know the population standard deviation, we wouldn't even need to do a study, because to get the population standard deviation, you have to have all the data, and then you can get the population mean even easier. So what's the point? Right? If you can be 100% confident, there's no reason to do a confidence interval if you know everyone. So we don't know the population standard deviation. And because of that, we can't really put sigma in the calculator to come up with these areas. Does that make sense? Because we don't know sigma. And I'll give you a little bit of a history. It has everything to do with beer. I'm sure that's what you're thinking, right? Like drinking beer. It turns out there was a professor, a statistics professor, and he had two jobs. One was teaching stats, and the other was doing statistics and other studies for a brewery. Long time ago, like 100 years ago or something. I don't know exactly how long, but it was a long time ago. And he realized that when he was doing it using this normal distribution curve, it was his career and he wasn't being right 95% of the time. He was being right a little bit less. And what he realized was it had to do with using the sample standard deviation to estimate the population standard deviation. And when you do that, you actually have more error. So what he did, which is way too hard for this class, it's way too hard for anything community college, even for second year calculus students, is he came up with a new distribution curve that works in this error of using S instead of sigma. And he named it after his students, and he called it the students' T distribution. So for short, we just use T. So you'll often hear the T distribution. And that's actually, it's a slightly refined distribution that's not perfectly normal. It's slightly different. The math is way too hard for me to explain. But it uses the T distribution instead of the normal distribution. So again, you're not responsible for any of the mathematics behind it. But I will let you know using a T instead of a normal when we're doing this calculation. Any questions on that? Okay, so if there aren't questions, I'm going to call it a day, but I'm always happy to answer more questions. So I'm going to stop my share, which means now you could ask questions that you don't have to worry about being on YouTube.
And stop the recording, I suppose.
Oh, stop the recording. Yep. Sorry, now you can. Thanks. Thanks, Braulio.